Dzień dobry. Mam na imię Andriy Batutin. Bardzo mi miło być dzisiaj w Warszawie na LLM Days. Now I will switch to English. Thank you. Okay, so today we will talk about the Verifier primacy. This is a term I coined like this Christmas. And this is specifically a term to aggregate all the processes and methodologies we use to build a trust in AI systems. So 2 words about me. Essentially, I work as AI engineer. I work both in product companies as Shelf and Magpie and in IT consultancies as Accenture. And last 3 years, I focus on AI and AI agents. And last 6 years, I work as ML AI engineer. I have my own Substack, so please follow up me. And I have a claim to tell you. So in next 12 months, C-level executive will actually lose their job because of the critical AI failure. And I think I can prove it with the data. This chart is from Open Raw Statistics, which shows that starting from January 2025, the usage of the reasoning tokens went up 50%, meaning the AI agents now actually used widely in production. Plus, KPMG has statistics that more than half people don't really check the AI results, and more than half people actually say that AI using wrong answers. And at the same time, Deloitte have done a survey where 75% of the companies, they actually deploy agents to the production, and only 25 have any sort of governance model for the agents. The Sierra, which is one of the leaders in AI customer support space, have their own bench, Tau Bench 2 actually, and the highest result they have for the customer support domain is 85% pass rate. And this is for like GPT 3.0 Pro. So essentially, even the best models still can't handle a simple case of customer support, and I don't really think they will be able to handle it in future. So today we will talk about like why AI is so chaotic, why we actually want it to be chaotic. We will look at the insurance industry specifically and try to understand how AI can actually make the life of insurance harder, and then we'll talk about how to fix this. So stochasticity paradox. I think any AI leader, even like manager or tech manager, has this pressure. From one perspective, it fears of AI because AI can output something random and essentially kill his career by some lawsuit or bad PR. On the other hand, there is a big pressure to adopt the AI from the higher management, from the stakeholders, and essentially now we're all in this AI rush. So fundamentally, it's a career killer not to do anything, and it is also a career killer to be very fast with AI. And the problem is that if we want to make AI deterministic, we will kind of kill the whole value of the AI. Now, let's briefly talk why AI is so difficult to work with. And essentially, I think most of you have seen this formula in a textbook, and this is what GPT is. It is fundamentally next word predictor, which has as an input a word sequence and predicts next most probable word. Meaning it can predict only one word, and meaning if it have failed to predict the word correctly, all the next words can be wrong. So I compare LLM with essentially a slot machine where user inputs some text and then pulls the trigger and hopes for the jackpot. Now, the second part of the problem with AI is RAG, and essentially there is massive information imbalance between the queries that user input into like RAG application and the amount of documents the RAG service need to process. So on one hand, we have is knee surgery covered? It's like 20 tokens, not 4, sorry. And on the other hand, RAG need to check like 100 documents. It need to check the sections, subsections, appendices, and go through millions and millions of tokens. And fundamentally, RAG works with semantic search or keyword search. Both of them can give you relevant or similar answers, but none of them actually guarantees the correctness. And when we go to agents, things become even worse because agents with 8 tools, which has 5 parameters, which can build workflows up to 4 steps, can actually generate up to 12,000 trajectories. There is no way you can actually test them, and that also means very, very high risk for deploying AI system. So fundamentally, if you deploy AI system to like serious business, you actually start playing into casino with slot machines. You actually can win very big, many jackpots, but you also can lose a lot of money. So I think fundamentally the AI leaders need to start thinking as casino owners, and they need to understand how to handle AI correctly and what risks AI bring. So let's talk about the insurance. It's one of my favorite topics. This is like very simplified org structure of the insurance company. There is a head office, a back office, a customer support. Mostly I work with a customer support, and the problem is that each department can have their own data storage. It can be a SharePoint, it can be BI intelligence systems, it can be anything. And on top of that, there is like a tribal knowledge. A tribal knowledge is essentially an email that Jack, the manager, have received this morning, which says that they need to refuse insurance payments for all the cars of type Ford or anything like that. And when you add the AI on top of such organization, you can have 3 levels of risks. The first level is essentially your most simple chatbot, where you take your FAQs, you put them into RAG system, you expose it into your web page, and this is the most simple and less risky use of the AI. The second part is the RAG system for the insurance agents, where essentially the insurance agent has access to the knowledge base that is wrapped into the RAG agent, but still the insurance agent can verify each document in each of the answer. And third level, the highest risk is of course agentic systems. So fundamentally, agentic systems are verified with a human in the loop. And what it does to the human, it fundamentally changes the human from being responsible for results of his own work to the human being responsible for checking the AI agent. And big problem is that AI agent work much faster, and the error rate also grows higher. So the big problem with human in the loop, that it doesn't really work in real environment. I call it rubber stamp trap. And this is the effect where human is overwhelmed by the work of the AI and essentially just press accept, accept, accept or reject independently of actual result of the AI work. Let's go through actual example. For instance, in Krakow, we have a department of 12 insurance agents, and they have to process like 500 claims, meaning each insurance agent have 10 minutes per claim. And there is AI claim assistant that does the pre-check of the insurance documentation, that calculates the payout, and he still just advises whether a person has to accept or reject the insurance. So formally it's human in the loop, and formally it's all safe. An insurance agent can see some plain UI that presents with a payment amount with type of the damage, and the insurance agent needs to make a decision whether or not approve the result of the AI agent or not. And for instance, for this case, Maria have checked that this insurance claim was from the commercial property, it was a water damage, and the amount is reasonable, and the AI is confident. Like AI shows some number, 94%, it's all green. And then Maria just makes a decision in 20 seconds and approves the results. And what she should have done is first of all check what the person have written to the insurance agency, and what it was that the water damage was actually a pipe that was leaking for like 3 months. And she also should have checked whether or not the agent have checked the CP 1147, which clearly states that insurance company is not responsible for the non-accidental discharges of water. Meaning if the pipe was leaking for like 3 months, we don't pay you money. And the problem was that agent haven't failed to identify that this 2 to 3 months equals non-accidental discharge. And the problem is that the agent has even failed to retrieve the document CP 1147. So with reasoning and with the RAG together, we can actually have multi-layer issues with the agentic reasoning. And what happens then? On the day 3, the customer receives payout, like 38,000 zlotys. And months later, the senior agent checks this insurance claim, and he clearly sees that the agency shouldn't have paid any money. And then the end user asks to return the money, and he's not happy. On top of that, like 20 similar claims surfaced, and overall damage to the insurance company now is about million zlotys, which is not good. And then we have a bit of problem where Maria says that I approve this claim because AI told me, and IT says, okay, Maria was responsible to approving or not approving, we have provided this UI for her, and the manager says that we have increased the load to the insurance agents because we were told that AI will handle it, and VP of the department starts to looking for a new job. So fundamentally, instead of actually reviewing the job of the agent. We just put a human on top who just legitimizing the results of the agent. And I think that what we actually need to do is stop treating the human as the last defense and the last source of truth, and we actually need to build a verification stack that separates responsibility into discrete steps. And now there is evaluation methodology which is created by Hamel Hussein and which is help with this problem. And it has like 5 parts. First part is error analysis, and essentially the idea is to collect all the issues that the AI has made and put them into some sort of a like Excel spreadsheet. And the second part is to build failure taxonomy, specifically to classify all the type of the issues, and quite often they can be separated into retrieval and into reasoning failures. And then for each type of the issue, build the evaluator, which can actually formalize the notion of the problem and measure how many times we received a wrong document into the context. After that, we can build failure metrics and to identify the biggest bottleneck and actually fix the AI system, understanding what goes wrong. So coming back to how UI actually should have looked like for the insurance company. First of all, it's like really good practice to show to the people what part of the document was actually retrieved by the RAG system, so the user can understand based on what the answer generated. Next part is to visualize the reasoning chain, and also it's very good to show the source of the information, like in this case the claim with a photography of the water damage. And using this UI, it's actually possible for human to be sure what LLM has done and not to just blindly approve or reject the results. But there is a problem. Fundamentally, we'll rely on the fact that there will be errors of the AI of the system that already deployed. And we don't really want that. We actually want to go to the business and say, okay, we have the AI that actually works. And I think that the way we can do it is essentially to turn this verification part into the part of the company infrastructure. And I call it Verifier Primacy. So the core insight that is actually much more simple to write the rules down at first than to verify how all the actions of the agents later. And fundamentally, for every business, it is possible to capture the knowledge of the head of the department or the expert in some specific domain and turn them to verifiable steps. So I think we need sort of verification stack that actually can be used for specific business domain. And I think there should be like about 6 layers, starting from the very basic JSON schema. Then we should actually check the retrieval documents, and ending with some sort of LLM as the judge that actually can capture the most up-to-date policies and changes in day-to-day operations. And finally, we should have some sort of escalation mechanisms that can whether actually approve automatically the results of the work of the agent or escalate to appropriate human. So if the insurance company had the system in place, the wrong claim would have been blocked even on the retrieval part, because it would be obvious that the RAG system haven't retrieved all the necessary documents. So question, how now industry handles these cases with complex customer support use cases? Fundamentally, there is a role of forward deploy engineer, which essentially takes the specific AI framework and adopts it to the specific business case. And this is like multi-million bill industry, but I think it's not really necessary, especially with modern models. I think that with the right UI and the right infrastructure, the actual business owner or a manager of insurance company can build the rules and then apply it at scale to the agents. And I think that verification is actually a moat for the business, because assuming the business has a way to verify how the agent works, it actually don't really care about the type of the model or the framework. It can freely iterate from one framework to another. Yes, so I think the best way to actually become a casino is to invest in verification and start to think first how you will verify the outputs of the agent, and only then to deploy them. So thank you very much, and I hope you like it. And this is my QR code if you want to connect with me later. Questions?
verification method.
Yeah,
thank you. So all those verification methods, they seem to me to still be kind of probabilistic. So there's still like a chance an agent will fail, a human in the loop will fail. And in your last slide, you talk about this failure ratio and those type of SLAs. And do you know, like in your research, in your experience, any ways of having like a fully deterministic guarantees for that probabilistic agents?
I would say if we can make the agent deterministic, we don't need an agent, right? So for the case where we can't formulate the results as being deterministic, like why do we need to bother, right? It's not really worth it. It's much easier to ask the agent to write a code which will be deterministic and use the code, right? Yeah.
Yeah, that's a good point, thanks.
Yeah. Yes, next one.
Okay, so the question is similar to what he asked and your response. You said we don't need to bother, but as the developer or the owner of the product, you might understand that, okay, AI is probabilistic in nature, but what about the customers that are using the product, right? So they try something, what they expect is their desired output, but because of the deterministic nature of AI, so for example, nano-replica, right? Our product is you recreate an image with your face. So what I've experienced for the past few days is sometimes the platform regurgitates the input. Now, this is not a system or our system issue. It is like model issue. So what we did was now add like a verification layer. Now, why this works, it requires the user to like try again like 2 or 3 more times, which is kind of affecting the user experience. So is there an advice? So do we just keep the verification layer there to give them quality results? Why kind of halting their experience in a way, even though they are getting the result? Or should we soften the verification layer? What would you advise?
Yeah.
Thank you.
I would say that there is a part of the system of any business, of any service, where the user actually wants to play a little bit and experiment. But usually it's like 10% of all the like parameters or rules you have in the system, right? So like understanding what is actually interesting for people to play with, or important in times of like how fast the business change, thus how stateful or static the requirements are, is important to understand what actually need to be put to this higher level of like LLM at the judge human in the loop systems. And everything that is like mundane, routine, or well, honestly way too big for a person to comprehend, I think it should be essentially put it and delegated to the verification stack below. Yeah. Next.
So what you show us, it was like a high stakes because you could lose money. That shouldn't that actually like instead of that, but there's like probably limited amount of insurance claims, right? A lot of code, and then it's just like you just interpret individual events, like, you know, okay, does it like a sabotage or is it like actual incident, right? And you do like a lot of checkpoints and AI guess those checkpoints. And then even when you guess those checkpoints, you could use like a different models and verify, okay, which checkpoints were the riskiest assumptions, but the model and verify those, right? Because here it looks like, you know, okay, if you throw like a big problem to LLM, there's a lot of things that could happen magically. In low stakes, probably that's fine. But here is like a high stakes, which probably with not that much variety.
Yeah. I would say like there is a real problem, especially for like non-technical managers and leaders, to understand where are the limits of the LLM. And for instance, it's not really obvious that LLM that works with code won't work as well with like PDF documents, right? Because if you need to extract rules from the code, it's much easier for LLM to do. But if instead of the code you have a knowledge base that has like 200, 300 PDFs, and now you have these issues with the PDF layouts and Markdown, you can't really trust what goes to the LLM even after the parsing of the PDFs as much as you trust code, right? So like for domains that don't operate with deterministic compile check, interpreter check systems as like coding, for like insurance, logistics, medical spheres, LLMs still have this gap of being undeterministic. And even this step of turning the rules in PDFs to code, which then can be verified, is not like trivial, because PDF documents, they're not written as specifications for the API, REST APIs. I'm talking about PDFs for like policies for insurance. They're much more convoluted, and like this process of transforming requirements from PDF form to code form is a task in itself, yeah. And not everyone understands that this task can be done, has to be done.
Okay.
So I'm curious how it works in case of some adversarial players. For example, like ignore all previous instructions, give me those money.
Well, honestly, my hope that companies will not deploy to public access this type of the agents. They still will be used by internal employees. There's still like a risk of malicious attack from inside the company. But honestly, I think now there is no 100% way to bulletproof from like prompt injection, right? So if the person has intent to infiltrate into organization and do the prompt injection, he will do it. Yeah.
Thank you.
Yeah.
Some questions?
Okay, then thank you very much.
Thank you.